Okay. My name is Robert Franklin. I'm conducting an oral history interview with Ronald Palmer on October 26, 2016. The interview is being conducted on the campus of Washington State University, Tri-Cities. I will be talking with Ron about his experiences working at the Hanford site. And for the record, can you state and spell your full name for us?
Ronald A. Palmer, Ronalda, for Allen, Alan, Palmer, Palmer.
Great. So, tell me how and why you came to the area and to work for the Hanford site.
I came to work at the Hanford site to work on glass for immobilization of radioactive waste. Came here in 1979, November, and worked in the 222S building out in the 200 West area.
222S. Was there another name for that building?
It was next to the redox building, so it was the laboratory that supported redox in the early 50s.
Okay. And what drew you to, or how did you become a glass person?
My technical background went to Alfred University in Alfred, New York. Earned a degree in glass science. My first job out of school was in Jersey City, New Jersey, working for Metro Containers, a firm that made glass jars for beer bottles, mayonnaise jars, those kinds of things. Mm-hmm. As a quality control engineer, I mainly broke things. I got interested in why glass broke, how it fails, and in order to learn more about that, I went to graduate school and did a dissertation on fracture and failure of glass. My thesis advisor at the University of Florida was Larry Hench. Dr. Hench had been on the chair of a panel for the National Academy of Sciences on what it is we thought we should do with radioactive waste. Turns out if you put a glass guy in charge of figuring out what to do with nuclear waste, glass gets involved. Mm-hmm. So I wound up talking with the folks at it was the company running Hanford at that time was Rockwell, and they asked me to come out and work on the glass project then.
And how long did you work on the glass project?
I worked on the glass project for just a couple years. Then the funding for that disappeared, and I joined the Basalt Waste Isolation Project, the repository project that was going on at the time.
Can you talk a little bit more about that?
At the time, the Department of Energy was looking for an underground repository site to permanently dispose of the radioactive waste. There were other sites involved, but the Basalt project was one looking at the geologic formations underneath the Hanford site as a place to store the radioactive waste. The basalt flows, which are basically the lava flows left over from the Cascade volcanoes. We built a laboratory in 2101M building in the 200 East area. It had been a big warehouse, and we built a laboratory there with electron microscopes and spectrometers of various types. We were basically a geochemistry laboratory. We were looking at the properties of the basalt rock underneath in the formation underneath the Hanford site, and the relationship of the properties of those rocks with the glass compositions that we expected to make. So we did some experiments that involved glass and the rock, and simulated groundwater, those kinds of things.
You mean storing glass in the rock, or?
Well, the glass was expected to be the waste form.
Okay.
So when you dispose of the waste, you put the waste form, which what they've eventually done is they make the glass and they pour it into stainless steel canisters. The design we used were 2 foot in diameter by 10 feet tall stainless steel canisters. And so with the glass in there, you expect after several thousand years, the canister has become compromised, and you worry about the reactions between the water, which may come into the repository, and the glass and the rock.
And so what did you find about that situation, or can you describe a little bit more of the work or the results of that work?
We were looking at ways to perhaps slow down the inflow of water into the repository. One suggested method was to backfill the holes that you drill in the ground to put the canisters with a bentonite clay. The water would come in and it would first see the clay, and the clay would have a tendency when it gets wet to swell and to slow down, if not stop, the inflow of the water, and therefore extend the life of whatever waste form you've put into the ground.
So
we looked at various options that we might design into the repository to minimize the eventual damage that you will expect to have happen from water coming into the repository.
So that clay then would kind of act to like plug the
Yes.
the leak of the.
Yes.
Oh, interesting.
The term we use for that would be engineered barriers.
Engineered barriers.
So you basically find materials that would help keep the water out, and design that. That would be an integral part of the repository design.
And were these results adopted here on the Hanford site or elsewhere, or?
The repository program, the basalt project continued, I think, until 1987. Let's see. The original act of Congress that was involved with nuclear waste was in 1982, and that provided for the investigation of 3 different repository sites: the basalt site underneath the Hanford facility, a formation of a material called tuff outside of Las Vegas, which is called the Yucca Mountain site. And they were looking at various salt formations in Texas and New Mexico and Louisiana and other places as a third potential site. By 1987, they had determined that it was too expensive to look at all 3. It's not cheap to do that sort of research. And they narrowed it down to the Yucca Mountain site outside of Las Vegas. So at that time, I think the other repository sites projects disappeared. I was gone from the project by then. I left the project in 1984. So.
Oh, okay. And where did you go when you left?
I went. I was out of the nuclear waste business. I went to 3M in Minnesota.
Okay. And what did you do there?
I did research on new glass compositions, in particular a material called bioglass. Another topic of research for my former professor, Dr. Hench. He invented a material called bioglass, which chemically bonds to bone in the body, and is now it's being used as a dental material, not as a solid piece, but as a powder to help with the bones recession of your bones if you've got gum disease and that sort of thing. You can place a powder of the bioglass, and it will help the bone grow back a little bit.
Oh, wow. Interesting.
It's also being used in toothpaste to help fight gum disease and that sort of thing. So, but I did a little bit of that work for 3M, but not very. I also worked on some composite materials. that they were designing.
So now you're kind of back in dealing with, or later on you returned to dealing with
Right.
with radioactive waste or nuclear waste. So can you describe that kind of transition back?
I joined West Valley Nuclear Services. There's a site that's now called the West Valley Demonstration Project, 30 miles south of Buffalo, New York. And I spent 15 years there. During that time, we tested a mock-up of a glass melter and how we would run the process, and then built the actual melter, and closed that in a hot cell, so where no one would go to work on it inside. So we had to make sure that the melter would operate remotely without having send someone in. The West Valley site had only one tank of radioactive waste compared to the 177 here at Hanford. So it was a fairly straightforward project. We were able to determine the chemistry of the waste in the tank, and that made it easy to just design one glass composition that we used. We made glass. We made radioactive glass from 1996 to 2002, and made 275 canisters. The canisters being 2 foot in diameter by 3 feet tall, by 10 feet tall, and those canisters are now stored. They remain at the West Valley site. Eventually, they'll go into a repository, assuming some repository is eventually made.
So did it take 6 years to vitrify? Or sorry, I guess I should ask: is that process is vitrification, right? So
yes.
That's the right word to use.
Yes.
Okay, so it took 6 years to do that for one tank of waste.
We designed the process to be small and relatively slow.
Okay.
To fill a canister when everything was up and running smoothly, it was about 2.5 days.
Okay.
Whereas the facility running at Savannah River right now, Defense Waste Processing Facility, DWPF, they fill a canister in less than a day. At the Savannah River site, if I remember correctly, had 53 underground storage tanks, so they've got quite a bit more than we had at West Valley, and also a variety of compositions, so they had to change their glass composition as things went along. They've now made over 4,000 canisters since 1996.
Wow. So then it does really depend on the chemical makeup of the tank as to what type of.
Yes.
So which is why I guess Hanford's waste poses a problem in that
yes.
aspect because of the unknown nature of.
Yeah, and it's also at Hanford. There's also a wide variety of compositions in the waste tanks, and so the glass compositions can be very different. So you really need to know what's coming in from the tank the next day in order to make the right mix of raw materials to make the right glass composition, and it's tricky. And also if you have to go from one composition to another, you have to know what you have in the tank before you add the new stuff, because the composition is going to change, and it's hard.
Do you think that the vitrification is the right choice for Hanford's waste, given its myriad of compositions in the tanks?
When Dr. Hench did his analysis of what materials to use to immobilize waste in general, glass is clearly the most versatile. There are other waste forms. There are crystalline ceramic waste forms. There are composite waste forms. A wide variety of things that you can use to immobilize the waste. But the processes for those waste forms are much more complicated, and it would be very difficult to say design a one of the waste forms is called a tailored ceramic, and where you design crystalline components of the ceramic to immobilize specific radionuclides and that sort of thing. It's hard enough to do for one composition, but to do for 177 compositions, that would have been very difficult. The glass is clearly the most versatile. Is it durable enough? The expectation is that the glass, the waste form in the repository will stay, the radionuclides are supposed to stay within the repository boundaries for 10,000 years. That's the bureaucratic boundaries that we have to design for. Some people say, yeah, it ought to be 1,000,000 years, but who would believe us if we predicted 1,000,000 years? We have trouble believing ourselves when we're predicting 10,000 years because it's tough to run that experiment.
Right.
From the standpoint of glass lasting that long, there are some researchers out there that have been looking at archaeological glasses that may have been in the ground, say, 1,000 years, and try to look at what glass composition, what the glass started out as. And in fact, somebody has done an experiment where they've excavated the dirt around the glass object and analyzed what is in the dirt that might have come from the glass leaching out and that sort of thing. And they've also discovered in shipwrecks in the Mediterranean glass bottles, amphoras, those kinds of things that have been at the bottom of the ocean for 1,000 years. And you can still drink wine out of them. So we like to think if the folks 1,000 years ago made glass that lasts at the bottom of the ocean for 1,000 years, maybe we can, on purpose, design glass that'll last for 10,000 years.
Interesting. Why was there the shift? So you came to work in glass immobilization, and then you said the funding for that program ended. How come that? Why was there that shift there in the late 70s, early 80s?
Well, if I remember correctly, the project I was working on was sort of under the table. If I remember, the Pacific Northwest Laboratories, this was before it was a national laboratory, had the responsibility of developing the glass waste forms. Mm. And what we were doing was just a very small project compared with what was going on at Battelle Northwest at the time. And I think somebody caught us doing that, and they said, you shouldn't be doing that, that's Battelle's job. So they found something else for me to do.
Oh, right. So Hanford's vitrification plant is in the news a lot and is kind of plagued
Yes.
by cost overruns and delays. And is that, being a vitrification expert, is that kind of, I mean, I'm not looking for you to criticize them or anything, but is that kind of the norm? Should we have been prepared for how complex this process is? Do you think maybe that wasn't communicated, or are there actual kind of real problems with the process that's being instituted here in terms of efficiency and actually, handling the mandate?
I'm a little surprised it's taken this long. I was back here after we finished the work at West Valley. I came out to the project that was, Bechtel had just taken it over along with, it was the Washington group then. And I came out, the Washington group was the organization that was running the West Valley project, so we were brother organizations. So I came out to work with some of the folks in the group to try to put together procedures and figure out what we expected to have happen over the project. So remember coming back here, and I think I still have a bumper sticker that says glass in 2007. And I probably got that in 2003. So I'll hang on to that. For it to have gone out this long, I don't know. I do know from having spent a lot of time at West Valley, the West Valley site, instead of here the Hanford site is 570 square miles. The West Valley site is 200 acres.
Mm.
The Department of Energy folks who were our overseers were right down the hall. They're not miles away as they are out here.
Right.
West Valley is also in the same time zone as the DOE headquarters in Washington. It's not 3,000 miles away and 3 time zones away. I think geography means a lot.
Right.
When you've got the folks you're working with and have to solve their problems, when you've got them right down the hall and you can talk to them day in, day out, it makes it so much easier to get the job done. And when they can call their folks in Washington where things have to get done in a relatively straightforward manner, I think that helps quite a bit. So it's the fact that Hanford is so big and it's so far away
Right.
from the people who ought to be thinking about it more, but they're in Washington, D.C. What do they care about what happens in Washington State? It's not primary in their minds. So you sort of get sent to the back of the room.
Oh. How does that compare though with you said the Savannah River site has created about 4,000 canisters.
Right.
How long is that process? Has there been similar delays or situation there, or how come that process is kind of up and underway? Or can you describe? I guess my question is, can you describe the similarities or differences between what's being attempted here and what's being attempted at another large site like Savannah River?
Savannah River always seemed to have priority over Hanford, probably because it's closer to population, and the environment around the Savannah River plant is a lot wetter than the desert out here. So if the 170, if the tanks leak out here, they leak into the desert. If they leak at the Savannah River site, they leak into the Savannah River, which feeds several million people.
Mm.
And so the Savannah River site did get more attention in the early days, and they've done a very nice job getting their plant up and running. And we worked closely with them when I was at West Valley. We talked with them all the time in terms of their day-to-day almost troubles and tribulations that we designed. Well, the melters were designed a little bit differently, and the canisters were a little bit different. The West Valley canisters had a large mouth, and it was a 16-inch opening. Pretty easy to hit the hole with the glass that's coming out of the furnace. Mm-hmm. The Savannah River canisters had a much smaller diameter hole, and that led to different processes for welding the material shut. But we could compare notes in how you do that and how the melters worked, and it was we were operating in parallel, I think. Let's see. If I remember right, Savannah River started their process up in March of '96, and we started in June.
Okay, so you were doing the same thing at the same time.
Right.
So they've vitrified a lot of their waste, but there's still no current long-term repository. Like
Right.
Waste is still being stored at individual sites, awaiting So really, that's kind of the other step of this process, right? Is finding a, or what are your thoughts on that situation? On the, do we need one or two major long-term repositories to kind of collect all the waste in one area, or is it better to keep it spread out at its separate sites?
It's going to be wonderful when we get all the liquid waste out of the tanks and immobilized somehow. I like to think that I'm a little prejudiced. The glass is the answer to that. And now that we've got the tank empty at West Valley and the material in glass, and Savannah River will get there eventually. They might be halfway through, or they may. I'm not quite sure how long they're going to take to get it done, but it'll be nice to have those canisters of high-level waste somewhere, and the high-level waste out of the ground. And with any luck, it'll happen here at Hanford too. There's no rush to get those canisters of glass into the ground. They will. We expect that they'll be stored safely somewhere in some kind of a building, some kind of a structure that will keep the water out, keep the animals away, and whatever else. So you kind of hope that that's going to happen. And if there's talk about reopening the Yucca Mountain project again. Mm-hmm. It was always kind of funny. Everybody complains that they shut it down a few years ago, and that was a political action. Well, picking Yucca Mountain was a political action in the first place. When in 1987, when they decided to go to just one repository, if you look at the state of Nevada versus the state of Washington versus, say, the state of Texas, Nevada has the least number of representatives in Washington. So it basically was a political act to create that there. So it doesn't bother me that it was a political act to have shut it down. It may be reopened again. Harry Reid, who was the senator who asked President Obama to shut it down, Harry's retiring. Mm-hmm. So maybe it'll reopen. I remember maybe 25 years ago I went to a PTA meeting, the New York State PTA meeting, and the national president was there. She was from Las Vegas, and I asked her about Yucca Mountain. She said, "You and I need to talk." She was not happy about Yucca Mountain, and she was amongst those who were really fighting against even looking at the site. There was let's see. When I was in Minnesota, about 1985, I believe, the Department of Energy was looking at a potential second repository. They were looking first of all at those sites out west, and then they started to look at granite formations, say in New Hampshire, the Canadian Shield, which is out state in Minnesota. So there were folks agitating in Minnesota that, oh my God, they're going to bring nuclear waste here. And I remember going to a meeting of the local congressman, and hearing people shouting about it, and I sort of, on the way out, I mentioned to him, I said, why don't you just let DOE come in here and discover that it's really not the place to put it? Because one of the main things you need to worry about is how do you get all the materials that's elsewhere to the repository. And the weather in Minnesota in the winter is not so good. It would make it difficult to bring material in. And in addition to the weather interfering with construction of the facility to begin with. So there were a lot of good reasons not to put it in Minnesota. So it was just a lot of fun to watch the action going on with the anti-nukes locally, and as well as the people who might have been more in favor of it. I also remember there was one of my colleagues at the Basalt Project was back in Boston. I think he was at MIT giving a talk about the repositories, and he said he noticed some of the kids in the back were sort of dozing off when he was talking about repositories in Nevada and Washington, that sort of thing. And then he suddenly mentioned that maybe in New Hampshire, and he said the kids sat up and paid attention. All of a sudden, it's up the street in New Hampshire, and yeah, so it gets people's attention when it's close at hand.
It's a real NIMBY issue.
Yes.
How did the work at Hanford, your work at Hanford, kind of inform your later work, or because you started your private sector career at Hanford, right?
Yes.
And so how did that inform your later work?
One of the most important aspects of handling radioactive materials is a quality assurance program, where you and those of us were doing research on the Basalt Project. Our first thoughts was, how do you do quality control, quality assurance on research? And how do you ensure that your experiments are right? Mm-hmm. And because you're supposed to be investigating unknown things, so maybe quality control, quality assurance is too much control on your process. When it first was imposed on us, we were very concerned about how we can do that. But then we talked to the folks who were quality assurance experts, and they said, what we really have to do is control the process. Make sure if you're using a particular instrument, a spectrometer or whatever, make sure it's been calibrated, make sure it's working properly, make sure you have standards to compare against your unknowns. So the quality assurance aspect of it actually made our work a whole lot better. We had to think about it a little harder, but that's okay. So when I moved from here to 3M and did research there, I kept those thoughts in mind. Okay, I need to do research on new materials, on new products, that sort of thing. But how do I set up my experiments so that I know I'm getting the right answers, or defensible answers, right, if not the right answers?
Where at least the processes. Yes, is defensible.
And that turned out to be an important part of my work at West Valley. So learning that quality assurance was a good thing has been a big help to my later career.
Can you describe Hanford as a place to work?
It's a different place. It was first very strange to get out here and you see people on the corner waiting for a bus, and everybody's wearing a badge. And that was coming especially from a college campus. That was a very different experience. And I guess I got used to it, but I wasn't happy with the atmosphere that sort of creates, having to wear a badge and that sort of jazz. And I remember when I was at 3M, there was somebody coming in and wanted to make everybody at 3M. I worked in their research facility in St. Paul, which was several dozen buildings, and they wanted everybody to wear. Somebody was coming in proposing that everybody at 3M wear a badge for corporate security and that sort of thing. And my opinion of that was that would change the atmosphere of the research park. And I later in my career I worked for Corning Incorporated in Corning, New York, and they've taken it to an extreme, I think. When you get up from your desk, you're supposed to turn your computer off, because even the guy next to you isn't supposed to see what you have on your computer screen. And you have to wear a badge, and you need the badge to go from building to building, or from parts of the building to other parts of the building. And it created an atmosphere that I wasn't happy with. I felt that it's necessary at Hanford, where you're working with hazardous materials all the time, but I wasn't. I thought that in a corporate world, I thought it was a little bit of overkill, but the folks at Corning Incorporated have decided that they need to have everybody keeping their mouths shut whenever they need to keep their mouths shut.
Right.
Although if you go out at night and you sit in a bar and you listen to the guys talking at the table next to you, you might find out some things that you wouldn't find out hanging around the corridors of the research park.
Right.
So,
what were the most challenging and or rewarding aspects of your work at Hanford?
Most challenging, I think, was some days getting to work, taking the buses out to work. Although that eventually, once you get used to it, you get reading done on the bus. There was for a couple of years I lived in Kennewick, and I took a van pool. So I would get up in the morning and walk to the corner and pick up the van and spend an hour, and then spend another hour at the end of the night coming home. And at the time, I subscribed to 2 magazines. I subscribed to the New Republic, which was weekly and on the left side of the political spectrum, and I subscribed to William F. Buckley's National Review, which was every 2 weeks, and on the right side of the political spectrum. I was obscenely well informed because I read them cover to cover, because I had the van pool time day in and day out. I worked with a lot of interesting folks, and I'm spending this week here getting together with some old friends. Since we were done making glass at West Valley, a number of those folks are out here now, and about a dozen of us got together last night, and it was a lot of fun to see some folks that I hadn't seen for 10 years or so.
Oh, that's great.
The aspect of working on a project that the whole world thinks they know about. Nuclear waste, and one of the things, the most common comment you get is, "Do you glow in the dark?" And it doesn't matter. That happens at technical meetings. It happens at PTA meetings. It happens on the plane going back and forth.
It happens to me every time I go to a conference. At least once.
Yes.
Somebody thinks that they're the first person that thought of that.
Yes. So it does make for interesting cocktail party conversation because everybody has an opinion.
Yeah.
And I mean, why don't we just put it on a rocket and send it? Well, rockets never explode, right?
No.
And even before Columbia and Challenger had their problems, I went to a meeting in Cocoa Beach, Florida, down the street from the Cape, and remember talking to someone who'd worked at Cape Canaveral for a long time, and in some of the tests that they did, they had one rocket that they called the Titusville Express. Titusville is the next town over, and the rocket went up and hung a right, and fortunately went over the city of Titusville into the water. But that's not what it's designed to do. So if you put radioactive materials on those kinds of things, you're going to make a mess in the water someplace or wherever it comes down.
Right.
So one of those, a glib, easy answer to, the further away you are from the project, the more answers you have to solve it. And that's true in a lot of different ways. People have, we can solve that problem. It'd be easy, just do this. Well, no. So that makes it a lot of fun. And now, as we've been talking about, now writing a book on the history of this topic, and it's a lot of fun digging in the background and trying to figure out how people 100 years ago were treating radioactive materials, and as they started to understand that, we ought to take into account time, distance, and shielding and those kinds of things. And it took a while for them to figure that out, and people got hurt and died from not knowing.
Right.
And in some cases, though, I'm finding as I read more that there's a lot of cases where they did know, but they just left the door open on the cyclotron, that sort of thing. Some of the guys who were working on that were basically cowboys, and they just treated it like your standard old whatever's going on in the laboratory. And okay, the stream of electrons in the cyclotron, if they left the door open, somebody was getting irradiated, but they didn't seem, you couldn't feel it, so
right.
What's the big deal? So, but you need to keep that door closed, and it's kind of funny to read about the people who, smart people, gone on to get wide renown in physics and that sort of thing, but they left the door open on a cyclotron because they didn't figure it was a big deal, or they were just careless.
Right.
So.
Right. Or maybe had a sense of invulnerability.
Yes. Yes. Physicists have a way of thinking they're invincible.
Were there any major events that happened in the Tri-Cities while I guess you only lived here for 5 years?
Yeah.
Were there any major events in the Tri-Cities when you lived here that stand out to you?
Mount St. Helens.
Oh.
That was May 18th, 1980. And we had been watching over the previous year. We would be able to see some of the minor eruptions that had been going on. And I think, if I remember right, it's 160 miles from here. Mm-hmm. It was a Sunday morning when it happened, somewhere around 8 o'clock or something like that. My wife and I were in the grocery store, and we were way in the back of the grocery store, and a friend came in and said, "Wow, did you see what the mountain did this morning?" And no. We'd been inside whenever it happened, and came out, and you see these puffy clouds. It kind of looks like cauliflower. The ash falls in like pockets.
Oh.
And that day, everybody basically stayed inside because our cars outside got covered with dust. I talked to a friend who went to work that day and took the bus out to the 200 West area, and he said you couldn't see the front of the bus from the back of the bus inside the bus. So
Wow.
it it was a dusty day, and that they had just bought a new fleet of buses that were all air conditioned, and the ash chewed up the air conditioning. So we we didn't have that new fleet of buses that summer, and we all rode unair conditioned buses that summer. And a lot of people wore the face masks for most of the summer going out on the bus during that summer.
Oh wow. So how did that impact the work at Hanford at all, or did...
I don't know that it impacted the work to speak of. It certainly woke us up to the Mother Nature's power. I remember there was someone here who had a photographer who had been going back and forth to Seattle, and he would stop at the St. Helens area and take pictures. And he'd gone over that the Saturday before. And I saw him give a presentation on this afterwards, so this is all secondhand sort of thing. And he decided he'd stay the night on the south side of the mountain. And he took some wonderful pictures the day before from that particular angle. Mm-hmm. And the next morning it blew, and when it blew, he was facing south, away from the mountain. He didn't hear a thing because the explosion went north, and all the sound and all the ash went north. And he was talking to somebody, and the guy said, "Look around." And he turned around, and you could see the plume going off. And he went back to the same places where he'd taken pictures the day before and had the same picture as the explosion is going on.
Wow.
So it was quite an opportunity for that guy to get those kind of photographs. And, and it was then the police were coming through, chasing people out. You got to get out of here because the snow cap was melting, and the floods, the Toutle River, I believe, was being overflowed. And he had to get out of there in a hurry, although he kept stopping every once in a while, taking pictures.
As any good photographer would.
Yes, and the cop would come and say, "You got to get out of here, guy." And I remember we later that summer, my father came out to visit. My father was an 8th grade science teacher, so we had a good time taking pictures and collecting ash for his science class and that sort of thing. And we drove around the south end and came up Interstate 5 and saw the destruction from the flood, and drove over to where the Toutle River had washed out some small bridges, and you could see where the river had gone down to its normal level, but you could see it was 10 feet up on the banks, and then there was a mark about 10 feet up in the trees above that where the water level had been. So it was mighty powerful.
Wow.
So.
Any memories of the social scene or local politics or other insights into Tri-Cities life?
We were part of the Jewish community, Temple Beth Shalom. It's a small temple. There's not a whole lot of Jewish folks here, but they had been here from virtually the beginning of the project. The temple was founded in 1950. And when we were here in around 1980, there were still people who were part of that founding organization. And
I'm sorry, where was that located?
Thayer Street,
okay,
south of Lee.
Okay.
I haven't been there for a while, and I understand they've remodeled it. So I'm not sure I would. I think I would recognize the building if I were to drive down it, but I haven't done that yet. I may do that later this week. There were quite a few interesting people who worked there, who were part of that organization. There were chemists and engineers who worked out at the site, and there were also part of that organization. There were doctors in the local community who were part of that congregation. and I still have friends who are part of that here, and I expect to see them this week. They didn't do a whole lot of other things. It was just my wife and I when we came out here. We had a son. My wife's name is Ellen Goldberg Palmer. My son was born here. My older son, Michael, was born August of '82. So he has roots here, but I don't think he's ever been back.
Okay.
So one of these days we have to bring him back and see where he was born, that sort of thing. We later had a second son born in Minnesota. So my sons are connected to the two biggest rivers in the continent, one the Columbia, one the Mississippi. So although neither of them really remembers having been near them, they were both raised in Buffalo, so they don't remember much about either Minnesota or Washington State. So we were very much involved with the synagogue. There were also quite a few mixed marriages. I'm not Jewish. We decided we'd raise the kids Jewish, but that's all right. Wasn't a problem. But there were a lot of other mixed marriages as part of the synagogue, and because of the wide range of beliefs of the synagogue, it was always an independent organization. There are a variety of Jewish movements. The two major ones are Reform and Conservative. Reform being a little bit more liberal. A conservative rabbi would never have married my wife and I because they just don't believe in that in intermarriage, and we had some trouble finding a Reform rabbi that would do that. But the synagogue remained independent for many years until something it was never clear to me exactly what happened. We took a vote, and it was always 50-50, and they decided not to affiliate with either the conservative or Reform movement. But then somebody decided we really need to do something, so they had another vote, and it went conservative. So they needed to have. They felt they needed to do something with the Sunday school, and have some sort of official imprimatur of one of the movements, and that caused a split. There, especially among those of us who were mixed marriages, and we had a meeting a couple of weeks later, and in our house, mainly because we hadn't had enough money to buy furniture for the living room yet, so we had a place where we could have lots of people meet and have chairs around, and we actually created another synagogue for those of us who felt we should be more liberal than the conservative end of it, and that went on for a couple of years, and I think it's consolidated again, but I don't know exactly what the status of the synagogue is now. So even among small congregations, you can have big divides, and that's there's a joke that somebody told me. They sent a Jewish astronaut to the moon to establish a community. And they asked him, why two synagogues? And he said, well, that's the one I go to, and that's the one I wouldn't go to on a bet. So you can always expect, 3 Jews in a room, you'll have 10 opinions. Politics, I don't remember much about. I wasn't very much involved in that. I was too worried about day-to-day working and family life, because I was new at both. So I didn't worry too much about other things. Right. But yeah, Mount St. Helens was the big one, and and our relationship with the Jewish community. That was the two big social parts of our life while we were here.
Okay. Could you describe the ways in which security or secrecy at Hanford impacted your work?
Not very much. The work we were doing was publishable. We did have to worry a little bit about the composition of the waste. I think some of that might have been proprietary, because knowing what was in the waste would give information about what was in the material that created the waste, which was for plutonium to make bombs.
Right.
So I think some of that information might have been proprietary. I didn't have to worry about it because I didn't work on that part of the business. I do remember at the Battelle Library in the 300 area, which was a wonderful place to go. The books there it was just a fun place to look around. There was a room down the hall that you had to have special permission to go in that had a lot of the processing information that was proprietary, and I always wanted to go in there, but I don't think my clearance wasn't high enough. We had Q clearances then, and I don't think they even have that anymore out here.
Yeah, not to my knowledge.
So, but the secrecy aspect didn't affect me very much.
How has the attitude towards nuclear waste disposal changed from 1979 until now, both within the industry and without?
I think a lot more people know about it than before, especially because of the national hullabaloo over Yucca Mountain. So people worry about that a little bit more than they probably didn't know they had to worry about it. And suddenly there's a big squabble over it, so, gee, maybe I should worry about this. The other facility that's been in the news lately is the Waste Isolation Pilot Plant in Carlsbad, New Mexico, WIP. Mm-hmm. About 2 years ago, there was an accident there. There was a small explosion underground, and they needed to figure out exactly why it happened and now what can they do to prevent it from happening again. So I don't think it's up and running just yet. They're still sorting out new procedures and that kind of thing. But yeah, people are hearing about it more than I don't remember anybody really. If I talked with old friends about nuclear waste in 1979, they say what? Mm-hmm. They really didn't know what was going on. They had no idea of where the materials were located, but nowadays they do worry about it more. There are folks with the nuclear power plants. We all know that there's the spent fuel being stored at all the nuclear power plants, and folks are starting to be aware that this is the right thing to do. And there may be it seems to take time for people to want to solve problems. It just it's like the kids in the MIT classroom. Okay, that's Washington State. I don't need to worry about it. And wait a minute, it's in New Hampshire. Maybe I do need to worry about this. Mm-hmm. And if you suddenly realize that, that nuclear power plant down the street, okay, there's no radioactivity coming from it, but there is this other stuff that maybe can cause a problem. And
there's spent fuel being stored there in the area that wasn't designed as permanent storage.
Right.
How has the approach to nuclear waste disposal changed from 1979 until now, or has it?
I don't know that it has. I'd like to think we're smarter about it. I like to think that we have better solutions for it now than we did then.
Such as?
The, the immobilization processes, the eventually we're going to have to ship the materials from one place to another. They've done tests on shipping casks and designed them so that they're not going to fail. And there are folks who are still working on new designs for shipping, say, spent fuel. I'm sorry, I think it's called used fuel now. From reactors where they're stored now to there may be some intermediate storage facility or some permanent storage facility. I suspect that we may eventually go to some kind of an intermediate storage facility, and where that would be is a hard question to answer. They're now looking at the process of siting a repository there. I forget exactly what the buzzword is for it, but it's basically an informed consent of the community. For instance, in order to cite the WIP project at Carlsbad, New Mexico, they basically got buy-in from the community, from the mayor to the Chamber of Commerce to the local citizens. There are other folks in the state of New Mexico who would rather it not have been there, but they live in Albuquerque, and that's a couple hundred miles away. So now you worry about, what do you define as community? Is it the people who live in Carlsbad? Is it the people who live in New Mexico? Is it the people who live in the southwest? So that the concept of informed consent is absolutely necessary, but defining it is very hard to do.
Right. Because you don't always get to choose, as a project planner. You don't always get to choose who has buy-in or who feels like they should, or
right.
You don't get to exclude some people just based off of your own.
Yeah.
They get to choose whether or not they feel.
Yeah.
They feel like.
And in the past, we've done horrible things where we just ignored people. There are places in the Southwest where they had uranium mines, and downstream from the uranium mines were the Navajo. There were. I've read somewhere, I'm assuming it's true, is that there was never cancer in the Navajo Nation until there was uranium mill tailings nearby and coming in the water supply from upstream. So, the informed consent will hopefully help us not ignore some people who ought to be part of the process.
Right. What would you like future generations to know about working at Hanford, or living in Richland during the Cold War?
We tried. We tried really hard to do the right things. I do remember early 80s, Ronald Reagan was elected in 1980 as president, and he was a little more hawkish than Jimmy Carter before him. And I got promoted to a manager's position, and I got invited to the vice president of the site, who every once in a while got new managers together to give them a little lecture and, welcome to management kind of. And I remember him saying something about yeah, Reagan's going to put us back to work. We're going to build more bombs and do all that sort of thing. And I think I said at that point to myself, I got to get out of here. Because if that was going to be the attitude, I mean, cleaning up the mess is one thing.
Mm-hmm.
Building new stuff that goes boom in the night, nah, I didn't want any part of. And that was some of the reputation that those of us who worked at Hanford is that, yeah, we want to make more bombs. No, a lot of us are here because there's a mess to clean up. Mm. And we were chemists of all kinds of varieties who wanted to know, okay, what is it that we have to do to make this not a problem anymore? And it's a good intellectual problem to try to solve, and an engineering problem to solve. And we don't want to make new things that disrupt the community. We want to take care of the mess.
What about the there's kind of an inherent contradiction in there, though, right? In that you find joy in kind of solving the problem and fixing the problem, but without the bombs, right? Without the desire to make the bombs, we wouldn't have the waste to clean up, and you might not have come here, or you certainly. I mean, your life, a lot of your life's work is encapsulating waste, which there is waste from energy plants, but you seem to have spent much more time dealing with waste from production plants. And so I understand maybe not wanting to see more new waste being produced, but that's kind of an interesting relationship that I think you have with waste.
Yes. I wasn't around to make the decisions in the first place. I like to think that I'm around to make some personal and professional decisions now. Let's say when you go to the grocery store, you have these plastic bags. In the back of my car, I always have with me the reusable fabric bags when I go to the grocery store, so I don't create the mess in the first place. I think that may be one thing that I've learned looking at the history of what we've done with radioactive materials and radioactive waste specifically, is that we could have done better if we'd have just thought about it a little bit. And so there's new problems all the time coming on. There's new industries coming on. The genetically designed or genetically engineered organisms, those kinds of things. There's nanomaterials. All these are new industries, and we hope that they're thinking about the potential for problems. And having worked a little bit with some of the folks in the nanoparticle business, they were looking at those problems from the beginning when they're designing their materials, especially in the ceramics field. I know of people who were there at the beginning of designing new materials, and they were absolutely looking at potential harm that the materials might do. So,
do you think that same kind of that same kind of forward thinking was there at Hanford during the World War II or Cold War, but that the kind of the importance of the initial mission overweighed concerns about the legacy of nuclear waste?
Yeah, they were in a hurry. So cleaning up garbage was at best a second thought. They got it out of the way and put it somewhere where it wasn't going to bother anybody for a while, and they'll worry about it later. And it took them a while for later to show up.
Right.
They suddenly noticed, I think it was about 1973, when they noticed that, there used to be 100,000 more gallons of waste in that tank than there is now. I wonder where it went. And that was also the time when organizations were created to look at environmental issues. The EPA
Right. Yeah.
was founded in what I think it was about 1970. It was one of Nixon's
Sounds about right.
one of the good things that Nixon did. EPA and OSHA, for that matter.
Mm-hmm.
I remember doing things in a laboratory as an undergrad that you could not do now. I mean, using benzene to clean glassware. Not going to happen now, but it happened in the '60s
Sure.
as a routine thing. That's how you clean the glassware, was boil it in a pot of benzene, because it did a nice job of cleaning the surface of Pyrex.
Oh yeah.
So,
Wow.
yeah, and that was another thing, is that I probably got exposed to more dangerous materials working in a chemistry lab than I did working in a radioactive lab. I know we took care of doing things in 222S, although there were some laboratories I didn't really want to go into, but you learn how to do good science and good laboratory experiments from the folks. The woman who worked with me as a lab technician, Sadie Kunkler, had been there since before I was born, in that laboratory. She started working there in 1950, and so she had 30 years of experience of how to work in a laboratory and how to.
This was here
at Hanford in 222S, and she taught me an awful lot in terms of how you work in a laboratory. And there were parts of laboratory experiments that I was not competent to do, but she was very, very good in the laboratory in terms of making sure things were clean. And when you're doing experiments with where you're trying to measure small amounts of material being leached out of a glass with water, everything needs to be clean.
Mm-hmm.
The water has to be pure with it, and since if you're looking at dissolving glass, it's mainly sand, silica, and if you know anything about the dust that's in the air, it's also sand. Mm. So your materials, in order to do a proper experiment, you need to keep the dust out.
Right.
Otherwise, your experiment is not going to be.
You have to purify your water too, so there's no
right.
silica in the water.
Right.
Right. Is there anything that I haven't asked you about that you'd like to talk about before we end?
We covered a lot of stuff that I hadn't thought about in a long time. Thank you.
Yeah, thank you.
I'm going to be talking to some other old friends this week, and I will. I think you know some of them. Steve Buckingham is one who's been part of this program. Mm-hmm. Michael Kupfer is another one that I worked with in 222S. I called him yesterday, and he wasn't sure who I was again. Who again? What? We haven't talked I haven't talked to him in over 30 years. So we're going to get together and talk some more. And Mike was here and had some very interesting experiences in the lab working on glass and other projects. And I think he might have some interesting things to say. There was, there was one thing I think that actually got me the job. Working with glass at high temperatures is a tricky thing to do, and one of the crucibles that you use is platinum. When I was in graduate school, somebody in the laboratory was making glass and used as a setter plate in the furnace silicon carbide. Silicon carbide can take the heat, okay. But if you happen to drip a little bit of glass on the silicon carbide setter plate and have it next to the platinum crucible will dissolve. And what happened in this particular case, the guy left the crucible with glass in it in the furnace, and he came back several hours later, and it was gone. You allow the furnace to cool, and you take out the setter plate, then you could see a ring of platinum that had been the crucible that was now part of the setter plate. And when I came out to Hanford and went out to dinner with the folks who were interviewing me, they mentioned that they had a problem with, they weren't sure what happened. They had a bunch of, maybe a half a dozen crucibles on a setter plate, and some of them dissolved. They caught it before they were all disappeared, so I eventually got to see it. But some of the crucibles had been eaten away. Mm-hmm. And because I had that experience before, my response was, "Oh, you used a silicon carbide setter plate?" And they said, "Yep." And I think that got me the job. The fact that I had had that experience, and so, and that was the kind of experience they were looking for, someone who would not make that mistake.
Right.
Because those little platinum crucibles are, $1,000 a piece or more.
Yeah, that's not a cheap material to work with.
So,
kind of happy accident, huh?
Yeah, well, a happy experience for me to have that available in my list of things that I've done.
Yeah.
So,
especially during the interview. Well, great. Well, thank you so much, Ron.
Thank you.
It's been a great interview.
It's been good. Thank you.
Okay.